Today let us solve exercise 3.3 sixth problem. Okay, the first one is if matrix A is cos alpha sin alpha minus sin alpha cos alpha, then we have to verify that A transpose equal to identity matrix I. Okay, from A we can find out A transpose. How to find out A transpose? Transpose is interchanging the rows and columns. You write it as first row as first column, cos alpha, sin alpha. Okay. Second row as second column, minus sin alpha, cos alpha. Okay. Then we have to find out A transpose A. A transpose A is cos alpha minus sin alpha cos alpha into A matrix, cos alpha sin alpha minus sin alpha cos alpha. Okay, to multiply two matrices, first we have to find the order of the matrix, 2 by 2, 2 by 2. Then we have to check the number of columns in this matrix is equal to number of columns in this matrix is equal to number of rows in this matrix. Here these two are equal. So A transpose A is defined. Okay. Then how to multiply two matrices? Sum of the product of first row with the first column and first row with the second column. Then sum of the product of second row with the first column. Then second row with the second column. Now let's find out first row, sum of the product of first row with the first column. Cos alpha into cos alpha, cos square alpha, plus minus sin alpha into minus sin alpha is sin square alpha. Okay, then sum of the product of first row with the second column, cos alpha sin alpha minus sin alpha into cos alpha. Next, second row, sum of the product of second row with the first column, sin alpha into cos alpha then cos alpha, sin alpha into cos alpha minus cos alpha into sin alpha. Then sum of the product of second row with the second column, sin alpha into sin alpha is sin square alpha plus cos alpha into cos alpha is cos square alpha. Here since cos square alpha plus sin square alpha is 1, cos square alpha plus sin square alpha equal to 1. Okay, that is equal to 1. Here cos alpha sin alpha minus sin alpha cos alpha will get cancelled. Here sin alpha cos alpha minus cos alpha sin alpha will get cancelled. So this will become 0, 0. Sin square alpha plus cos square alpha is 1. That is equal to identity matrix of order 2. So A transpose A equal to I. Next, let us find out if matrix A is sin alpha cos alpha minus cos alpha sin alpha. Let's verify that A transpose A is identity matrix. Okay, A equal to sin alpha cos alpha minus cos alpha sin alpha. A transpose is interchanging rows and columns of given matrix. First row as first column, sin alpha cos alpha, second row as second column, minus cos alpha sin alpha. Then we have to find out A transpose A. A transpose is sin alpha minus cos alpha sin alpha. A transpose A matrix is sin alpha cos alpha minus cos alpha sin alpha. How to multiply two matrices? Sum of the product of rows with the columns. Okay, here first row with the first column. Sin alpha into sin alpha is sin square alpha plus minus sin alpha into minus sin alpha is plus cos square alpha. Then first row with the second column, sin alpha into cos alpha plus minus cos alpha into sin alpha. Then sum of the product of second row with the first column, cos alpha into sin alpha plus sin alpha into minus cos alpha is minus sin alpha cos alpha. Okay. Next, second row with the second column, cos alpha into cos alpha is cos square alpha plus sin alpha into sin alpha is sin square alpha. Okay. That is, since sin square alpha plus cos square alpha is 1, here this value is become 1. Then sin alpha cos alpha minus cos alpha sin alpha becomes 0. Here this also 0. Then cos square alpha plus sin square alpha is 1. This is equal to identity matrix I of order 2 by 2. If you have any doubt in this problem, you can comment in the comment box. We can do the next problem in the next exercise, next class. Thank you.